All right, so this is the warm-up for Solutions Quiz 1. The first question says to complete the chart below with all the ways that you could increase the rate of dissolution of the given solute in a liquid solvent. Okay, so just to remind yourself, so when you think of a solid dissolved in a liquid solvent, so for example, our most famous liquid solvent is water. Okay, you can think of sugar in water, or you can think about, if you did this in class, think about the Smartie in water. Okay, how can we make those things dissolve faster in water? There are 3 different ways. Remember, you could agitate it, agitation. Agitation consists of stirring or shaking. You could raise the temperature. What does it mean by raising the temperature? It means to make it hotter. Okay, the last thing you can do is increase the surface area. What does that mean? It means to crush it, right? So if you have like a sugar cube, right? If you crush it into smaller pieces, then it's easier to dissolve, right? Okay, now on the other side, when you think about gases, this is different, right? So you got to think of carbon dioxide in soda. How do you like your soda? Okay, so this is not the same as the other side, right? So you got to think about it. Your soda, you like it cold. So that means we need to lower the temperature. Make it cold. Okay, that's how you get more carbonation. How else do you like our soda? We need to have more pressure. Increase the pressure. Okay, that's why when it's sealed shut, you got a lot of carbonation, and once you open it, it will eventually go flat because all the gases will disappear. All right, so hopefully you got those written down. All right, next you're going to fill in the blanks below. Blank, okay, this particular compound blank will conduct electricity in an aqueous solution because it is a blank compound. So here you got to look and determine if it's an ionic or a covalent compound, because that will tell us if it's an electrolyte or not. So remember the word electrolyte. It will light up because it has a current, okay? And the non-electrolyte basically will not light up, okay? So electrolytes are going to be ionic compounds. So these are ionic compounds, and these are covalent compounds. So let's recap really quick on the difference between the two. Okay, so right here, ionic compounds is when you have a metal with a nonmetal or a metal with a polyatomic, right? And covalent is when you have non-metal with a non-metal. The trick to help you remember this was I'm on CNN, right? So you have here your ionic compound, metal and non-metal, and then over here you have covalent is a non-metal and a non-metal. Okay, so let's do another quick recap here. You know that this chart is separated right here. There's a separation staircase. So your non-metals are generally on this side and your metals are on this side, except hydrogen is a non-metal. Okay, so let's look at our first example. The first example here is silicon with hydrogen. So you look for Si, you're going to look for the letter H. Okay, so here, let's spot them. Silicon is over here, and hydrogen is over here. Those are two nonmetals. If it's two nonmetals, then it is a covalent compound. So you're going to circle covalent. Covalent compounds, if you look right here, is a non-electrolyte, so they will not conduct electricity. It will not light up. Okay, so the next compound is magnesium fluoride, magnesium and fluorine. So you look back here, let's find them on this chart. All right, so magnesium is here. It's a metal. Fluorine is here. It's a nonmetal. Anytime you have a metal of some kind, you know it's ionic. So if you go here, you know it's an ionic compound. And ionic compounds, if you look here, is an electrolyte, so they will light up. Okay, last question here in this section says water has unbalanced charges and thus attracts and dissolves other blank molecules. So you got to remember that water is a polar molecule. It has unbalanced charges. So therefore, polar will dissolve polar things. Like dissolves like. That's why oil does not mix with water, because oil is non-polar and water is polar. All right, on to the next section. Okay, here you have your solubility curve, and so you're going to have to use this graph right here to determine these questions right here. Remember, unsaturated means you are under the line. Unsaturated means that you are on or above the designated line. All right, so let's do this question right here. So I'll do it in this color. 45 grams of KCl at 80 degrees. So you're going to look for 80 degrees. You're going to go up to 45, which is right here. Okay, according to KCl, which is right here, is it under, on, or above? It is under, so it is unsaturated. Okay, next. 70 grams of NaCl at 40 degrees Celsius. So you're going to find 40 degrees Celsius. You're going to go up to 70, which is right here. Okay, but it wants NaCl, so you got to make sure you're looking at this NaCl line. It is way above NaCl line, so this is saturated. Okay, next. 80 grams of NaNO3 at 10 degrees Celsius. So you're going to find 10 degrees Celsius, and you're going to go up to 80 grams, which is here. And it's talking about NaNO3 here, which is right on the line. So on the line means it is saturated. Okay, this last one here, you have 20 grams of KNO3 at 80 degrees Celsius. So you're going to go back to 80 degrees Celsius here. You're going to go up to 20 grams, which is here. KNO3 is all the way over here. Okay. That is way under the line. There is no line there, so it is unsaturated. Unsaturated, under the line. All right, on to the next section. Okay, so now you're going to determine what compounds are going to create precipitates and which ones will stay aqueous. Okay, so you have to use your solubility rules right here. So let's quickly recap. Remember, soluble means that it will be aqueous, and then there are exceptions. So unless it's attached to one of these things down here. If it's attached to one of these things right here, it will become opposite. It becomes a solid. Insoluble means that it will be a solid because it does not mix unless it's with one of these. And if it's with one of these over here, it's going to become aqueous. And all alkali metals are aqueous. Really quick, what are your alkali metals? Okay, they're the first column of your periodic table. So if I were to quickly write them down, it would be lithium, sodium, potassium, rubidium, cesium, and francium. Remember, hydrogen is not a metal. Okay, so let's use this chart to answer the previous questions. Here we are looking at LiCl and ammonium carbonate, lithium chloride and ammonium carbonate. So let's look at this one first. Chlorine is on the chart here. It is always aqueous unless it's attached to one of these. So is my chlorine attached to a silver or a lead? I'm going to go back. No, it is not. So it's going to stay aqueous. Okay, the next compound is here, NH4CO3. CO3 is over here. It's normally a solid unless it's attached to one of these. So the question is it attached to this or an alkali metal? So you look. Yes, it's attached to this ammonium. It's an exception, so it's going to turn it opposite. So this is going to be aqueous. Do we have a precipitate? The answer is no. There is no solid. Remember, this is saying, do we create a solid? And if the answer is no, then we do not have a precipitate. Okay, next you have BaOH, barium hydroxide, and NaCl, sodium chloride. So let's look for that OH. OH is right here on our chart. OH is always a solid unless it's attached to one of these. So you're going to look for NH4, an alkali metal, a calcium, strontium, or a barium. So you're going to look. It's attached to a barium here. This barium is an exception. It's right here. So it turns it opposite. So that means it's going to be aqueous, right? So we're going to go over here and we're going to put a Q because it is aqueous. Now the next one is sodium chloride, which is NaCl. So let's look for Cl. Cl is here. Chlorine is always aqueous unless it's attached to an Ag or lead. You look back here, it's attached to an Na. Na is an alkali metal actually, so you know it is always going to be aqueous. So the answer is no, we don't have a solid, we don't have a precipitate, so you can put an X right here. Okay, and this last one, you have potassium nitrate, KNO3, and lead bromide, PbBr2. So let's look for NO3. NO3 is right here. It is always aqueous. There are no exceptions, so it's always aqueous. So we're going to put AQ right here. This last one is PbBr2. So you're going to look for Br. Br is right here. Bromine is always aqueous unless it's attached to one of these. Is it attached to a Ag or Pb? So is it attached to a silver or a lead? So you go back. It is attached to a lead, so it becomes the opposite. It becomes a solid. So you are going to put an S right here. If you have a solid, you're going to circle yes. And then the precipitate is whatever that S compound is. So it's PbBr2. And that is a full warm-up. Good luck on your quiz.